we are currently looking at the builder pattern in action and going to build a SQL query builder. What is a SQL query builder? SQL queries can be of a variety of forms and can get inordinately complex. In order to avoid having to rebuild queries each time and knowing how exactly each query is constructed, we can make it easy to build up a query bit by bit as we get the information. That is what the SQL query builder helps us in. Using the SQL query builder, we specify the information bit by bit and get a final query at the very end. Now, let's say that we had code which needed to run a bunch of different types of SQL statements. You specify the SQL statements in some way, and this code had to go ahead and run it. Now, some of these SQL statements would be queries. Some of them will be updates, some will be insertion, and some deletions. So we have all kinds of SQL statements that we want to run from within our code. Also, each of these statements would have parameters specified only at runtime. So it's not like we can create a whole bunch of SQL statements in its exact and final form, because maybe some of these parameters come from user input. We would not have it at compile time. So we have this whole bunch of SQL statements that we want to run. Parameters to these statements will be specified at runtime. And also, just to be very clear, these SQL statements need to be called from within code. That is, you're using the Java programming language, for example, and these SQL statements need to be called from Java. The logical question now is, how would our code deal with the need for all these different SQL queries? That seems like a lot of different random work. There seems to be no consistency to this. So how would we do it? Let's look at two options that we have. We plan in advance for each type of SQL query possible and then create and store that query. So basically we know that these are all the possibilities of SQL query, that is SQL queries that are possible with the database that we have. We create all of these queries and we store it in advance so we can use the correct one when the need arises. That is one option. There is another option. We say we don't do anything about SQL queries. We don't know what SQL query it is that you want. So we rely on the client using our code to create their own SQL queries. Now remember, SQL queries can be arbitrarily complicated. And we just rely on the client to do this. Does this sound like a good idea? It's a possible option. Basically, we are expecting our clients to be smart. And that's not always a good thing. So if we imagine the options that we have in the form of a distribution, it would look like this. Option 2, in my opinion, is a bad idea. It's not really a good solution. In fact, it asks way more of the client than is expected. If we expect our clients to be really smart, chances are really good that they'll use our library in the wrong manner. So this is not a good solution. It asks way too much of the client. Expecting the client to construct arbitrarily complex SQL queries correctly for their use case is just too much. Then what's the use of your programming language? What's the use of your application? They might as well query SQL directly. Alright, let's go back to option 1 since we've said option 2 is not good. Option 1 is at the other end of the spectrum. Again, it's not a good solution. And why is that? That's because planning in advance for each type of SQL query that the user needs is frankly just too huge of a task. It'll simply not scale. You'll add a new table, for instance, or you'll add a column to a table, and all these stored queries will effectively be useless. In option 2, another thing you've got to remember that it requires the client to know SQL well, and it can even be a source of hacker attacks. Some users of your code might know SQL well and it's perfectly fine for them, but the vast majority will probably be susceptible to attacks. Now we know, let's go back to option 1. We know by now that any solution that tries to cover every possible case in advance is doomed to fail. More importantly, it also violates the open-close principle, because the internals of our program is trying to cover every possible case. Again, not a good idea. So we have options which are at the two extremes of the spectrum. Neither of these options are attractive. What do we need here? This is precisely a case for the builder pattern. A builder will allow us as a user of this library to flexibly construct very complicated SQL queries. It will provide just the right amount of abstraction from the tedious nature and error-prone nature of query building, and at the same time allow us to customize our queries the way we want it to. Let's take a look at some example code. This is a code for a SQL query builder. Let's take a moment and absorb what all this code does before we kind of dive into each portion of the code. The very first thing to notice is the private constructor. So we have a private SQL query builder constructor and a static factory method which allows us to get an instance of this builder. So why do we need a private constructor? This is because we want the builder to be gotten only by the builder class. We don't want anyone to instantiate a builder. Also, the constructor doesn't really do much in the builder pattern. So therefore, we have a private constructor and a new builder method which returns a SQL query builder, which we'll build up now. The next thing you have to notice here is the query type enum at the very top. This query type enum allows us a way to construct a select, insert, and an update query. You could easily expand it to more queries. For example, you could add a delete query here. This specifies the type of SQL query we want to build. What we want to do is query tables. Basically, the SQL query builder gives us a way to specify the tables that we want to use in our query. So note the table method which specifies the table name, or you can also use the table, specify the table name and the alias that you want to use within the SQL query. Alright, look at all the methods that exist after that. A whole bunch of ways to build up SQL statements of different types. So we have the insert columns, insert values, where statements where you can say where column is equal to column value, where not equal statements, group by, limit, etc. So these are these whole bunch of ways you can specify what is it that you want to, in your SQL statement. What is the where clause? What is the group by clause? What is the limit clause? Each of these you can specify. And then finally, we have a way to get the query which we've just built. So once you specify all of these, we'll use the get query, which will then go in and construct the query based on all the parameters you've specified and return it to you in the form of a string. So this is what a SQL query helps us with. This is what the methods are and how we can use them. Let's take a look at some of the internals of this method and then later how we'd actually use the SQL query builder. So the new builder just returns a new SQL query builder. The query type It just assigns it to a member variable and then returns this. So every method in the SQL query builder, after it makes the appropriate assignments, returns the builder itself. Note the return this after the query type method ends, the table method ends. All methods are constructed in exactly the same fashion. So why do we return a reference to this instance of the builder at the end of each of these methods? This is to help us build this up in the form of a chain. So let's take a look at an example of how we'd actually use the SQL query builder. We just say SQL query builder, new builder, specify the query type. It will return this instance on which we'll specify the table. That will return this instance on which we specify the select columns, and then the where equals, and then we call get query to get a string. By returning an instance of the SQL query builder that we are working on at any point in time, we can chain the builder like this. This makes for very easy to read and maintainable code. Now that we know about a builder, let's go back to the spectrum of options that we had. A SQL builder built like this and used in this way strikes exactly the right balance between asking the client to do too much or trying to specify every possible answer to the client's questions. So we are not asking the client to do too much, nor are we asking them to do too little. This is the optimal solution, the builder pattern. Hopefully these examples give you a very good idea of when the builder is used, how it's used, and how it can help us.